A vector can be represented as a directed line segment. Its length indicates magnitude and arrow indicates its direction. If a body moves in a curved path, the tangent drawn at a point on the curve gives the direction of velocity at that instant. Let us perform an activity for observing the direction of motion of a body. Click each tab to know more. Take an object which is tied to the string at one end. Try to rotate the string in a horizontal direction as it makes a circle. Now, release the string at any point on the circle. Observe the direction of motion of the object. Repeat the same procedure for different points. We will observe that the object will be moving in a straight line with respect to the released point. Similarly, we also observe that the direction of motion changes at every point when the object was released. From this activity, we learn that on being released, the object moves along a straight line tangential to the circular path. This is because once the object is released, it continues to move along the direction it has been moving at that instant. The direction of velocity is tangent to the path at a point of interest. The SI unit of velocity is meter per second. Let us know about the uniform and non-uniform motion. Consider a moving vehicle or bicycle which covers a distance 5 meters in the first minute, 5 meters in the next minute, 5 meters in the third minute, and 5 meters in the fourth minute. In this case, the moving vehicle covers 5 meters each minute. As the object covers equal distances in equal intervals of time, it is said to be in uniform motion. Suppose a moving vehicle or bicycle covers a distance 5 meters in the first minute, 6 meters in the next minute, 5 meters in the third minute, and 4 meters in the fourth minute. In this case, the moving vehicle covers unequal distances each minute. As the object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. If the direction of motion of the cyclist is assumed to be constant, then we conclude that velocity is constant. The motion of the body is said to be in uniform when its velocity is constant. Numerical problems. A man standing under a lamp of height h above the ground starts running with a constant speed v in a constant direction. The light from the lamp falling on the man forms a shadow of him. Find the velocity with which the edge of the shadow of the man's head moves over the ground if his height is h. Click the tab to view the solution. Let us perform an activity for observing the motion of a ball on an inclined plane. Click each tab to know more. Set up an inclined plane. Take a ball. Push it from the bottom of the inclined plane with a speed so that it moves up. Observe the speed and motion of direction of the ball. Now, release the ball from the top of the inclined plane. Once again, observe the speed and motion of direction of the ball. We observe that the speed of the ball increases gradually on the downward slope, but the direction of motion remains constant. Decreases gradually on the upward slope, but the direction of motion remains constant. In both the cases, we learned that speed of the object will change on the inclined plane, but the direction of motion of the object remains constant. Let us perform an activity for observing uniform circular motion. Click each tab to know more. Take an object which is tied to one end of a string. Try to rotate the string in horizontal direction as it makes a circle. Now, draw its path of motion and velocity vectors at different positions. Assume that the speed of the object is constant. Observe the velocity of an object. We will observe that the object will be moving in a circular path with constant speed, and the direction of velocity changes at every instant of time. Finally, we have learned that the direction of the velocity at any point is given by the tangent to the circle at that point during circular motion. The direction of motion is therefore continuously changing, but the speed is constant. As we know that the direction of velocity is tangent to the path at a point of interest, so the velocity is not constant. In this activity, we learned that though speed remains constant, the velocity of the object changes continuously, because magnitude of velocity is constant along the circular path. The only change in its velocity is due to the change in the direction of motion. Let us perform an activity for observing the motion of an object thrown into air. Click each tab to know more. Take a ball. Throw it into the air while making some angle. Observe the speed and motion of direction of the ball.